Good morning, everybody. We're going to get running pretty quickly here. Just going to give a minute or two to let everybody else trickle in. All right, then, as we are about to get rolling, we're going to just get some housekeeping out of the way at the start. So welcome, everybody. Thank you for attending our webinar. My name is Keaton Cottrell. I'm a marketing specialist with AGS and ATS Traffic. This webinar is being recorded, and we will be sharing the full recording on our social media and in a follow-up email with everybody. So if you miss anything, or if you have someone you know that might benefit from the info we're going to be talking about today, don't worry, you'll have a link, you'll have an email. It'll be quite easy to share and go over the presentation at a later date. If you have any questions during the presentation, please feel free to put them in the Q&A chat channel that you'll find at the top of the webinar window. At the end of the presentation, our hosts will be going through them and opening the floor for more discussion, more answers, following up on anything they might have glossed over a little bit or going into more depth. We expect the presentation to take about 45 minutes, hopefully leaving about 10 to 15 minutes for Q&A. Just a couple more people coming in. Other than that, we'll be sharing contact info and details on Liveable Cities and ATS Traffic in that follow-up, along with the recording, as I mentioned. I think that's about everything on my end. So I'll hand things over to Steve Henderson, our Director of ITS.
Thanks, Keaton, and thanks everybody for joining. We appreciate you taking some time out of your day to join us for this webinar. So as Keaton mentioned, my name is Steve Henderson. I'm Director of ITS for ATS Traffic and AGS down in the Pacific Northwest. With me today is Mike Andrews. Mike, do you want to introduce yourself?
For sure. Thanks, Steve. Thanks, everybody, for taking time out of your day today. My name is Mike Andrews. I'm the account manager for Smart Cities for Liveable Cities, working closely with Steve and our partners at ATS. And Steve and Keaton and everybody, thanks for having me today.
Yeah, thanks for joining, Mike. Appreciate it. Okay. As we go through, just we'll dive into the content, but we did want to take a little bit of time just to update everybody on ATS Traffic, what we're about, what we're working on these days. So ATS Traffic, simply, we're at our core, we're a safety company. Our vision is getting people home safely every day, and as it says there, our mission is to be the most trusted industry provider of traffic control products and services, supporting safer, more efficient roads and public infrastructure. Our days always start with safety, and that's at our core. That's the thing we do, is get people home. So it's a big year for us, though. 2026 is our 60th year. ATS started back in 1966 as a barricade rental company and have grown from there. So make sure you follow us on all our social media channels. There'll be different events happening throughout the year, celebrating our 60 years in business. So make sure you stay tuned for all sort of exciting things that are going to be happening this year. So about us, as I said, 60 years of experience, 16 locations, have over 8,000 customer accounts. We are the largest 3M certified sign manufacturer in the country, producing over 1,000 signs a day of all different types, sizes. We are probably, I think, arguably the largest traffic product and safety product provider in the country as well, with over 15,000 product SKUs available. So everything from barricades and signs all the way up to, LiDAR, radar, different technology equipment. If it has something to do with the road, we've probably got it. And then staff, we are over 700 staff now, North American wide. So our growth has been significant in the past 5 years, and then 68 sales and customer support staff to help you as well. So just on our distribution network, you can see there sort of the growth that ATS has had over the years. So our most recent locations opening in Grand Prairie in Alberta, and then down in Portland in Oregon, and then we stretch from Ottawa all the way across here to where I am in BC, in Surrey at our ITS office here as well. So significant reach, and that gives you access to local experts, and then all our integrated distribution network as well. So we are proud members of a number of industry organizations, as you can see there, not the least of which is the group procurement organizations that we participate in. So Canoe, Kinetic GPO, and Sourcewell. I'll touch on those a little bit closer to the end of the presentation, but we're very proud to be members of all these organizations. Okay, and then our partners. So we partner with frankly, some of the best providers in the traffic industry, a lot of innovative tech companies as well, not the least of which is Liveable Cities, who we're going to talk about today. But you can see there's some of our well-known partners that we deal with in the traffic and the ITS space. So our solutions, ATS, like I said, obviously the largest 3M certified sign manufacturer, lots of road safety infrastructure, temporary traffic control and work zones, including traffic management plans, lane closures, all that sort of stuff that we do on our services side of our business. And then obviously our intelligent transportation systems, quite diversified portfolio within that. So we deal with detection, data collection as a service as well, where we help municipalities and the engineering consulting community as well, cabinets, UPS systems, controllers, your traffic signals, your red, yellow, green signals as well. Ped safety, whether it's RRFBs, driver feedback signs, the blank out LED signs that you see on the freeways, like lane control, that sort of thing. And then lighting as well. So whether it's LED retrofits or solar power lighting as well. So it's a full suite of solutions. I would encourage everybody to find our ITS solutions catalog on our website as well if you're looking for anything. Okay. With that, Mike, I'll hand that over to you, and we'll let you dive into why everybody's here.
Awesome. Thanks so much, Steve. Yeah, so I'm going to go through a little bit of company and solution overview related to our technology, and then we'll get into some samples and some applications, and work with Steve to kind of give you guys a good overview of our solutions. So we'll start with our company. Liveable Cities is actually a division of a company called LED Roadway Lighting. We're based in Halifax, Nova Scotia. We're a Canadian company. On the left is our head office in Halifax, and on the right is our primary manufacturing facility in Amherst, Nova Scotia, just on the border with New Brunswick. So LED Roadway has been around since 2007. We started, manufacturing high-efficiency LED streetlights through the knowledge of that asset and our expertise in high-efficiency LED roadway lighting. That kind of formed a natural progression into lighting control networks for command and control of public lighting, for maintenance, energy savings. And then in 2019, we launched this division, Liveable Cities, which is more focused around leveraging that asset to deploy data collection devices for various types of data within urban and rural environments. So here's our suite of sensors, and I'm going to get into this in a little bit more detail, but just as an overview, there's multiple applications for different sensors. We've got video, speed, particulate matter for air quality, and then noise and acoustic monitoring. So the biggest commonality that you'll see across the sensors is that black base. So the black base on the bottom of each sensor is actually a lighting controller. So what that allows us to do is to leverage your existing lighting infrastructure to attach sensors toollessly in areas where you want to collect specific types of data. And the way that we do that is through a standardized socket that's on almost every roadway light out there. It's an ANSI or a NEMA 7-pin socket. There are legacy versions of 5-pin and even 3-pin if you still have some of that older HPS lighting, or sometimes we'll see it in parks or on flood lighting. Our sensors are fully backwards compatible with the 5-pin and the 3-pin. But really the important point here is this is a standardized socket on top of your streetlight. Typically, you would find a photocell or maybe a lighting controller there, or perhaps a shorting cap. But without the use of tools, an installer can go up there, remove that existing photocell or controller or shorting cap, and then allow for the toolless connection of these sensors. They get their power directly from the power that's already provided to the streetlight and to that socket. So essentially within, a minute or two, these sensors can be toollessly installed on, your existing lighting. So we can really transform or piggyback off that existing asset, that existing infrastructure that's already out there and you've already invested in or is available. Perhaps you're renting it from a utility. And now transform that into a data collection device where you can target different types of monitoring very, very locally to where you want to collect that data. We design our sensors exactly the same as we design our streetlights and our controllers, very suitable for harsh environments. We've got deployments all across Canada, where I am in the East Coast, where we see sort of those large temperature swings. Out in the West Coast, in the prairies, where you see those really sort of deep dive winter temperatures, Northern Ontario, as well as BC. We've also got deployments in multiple areas in the US, as well as the Caribbean, some of those areas where you might see more higher temperatures or perhaps salt spray in coastal environments. So these are very much to design and designed to operate in, all those different environments that we encounter where you're going to have your public lighting. And really what the micro sensors provide is it's a scalable way to collect data. The sensors are very, very modular from a hardware perspective. They can be temporary, they can be more permanent. But essentially, you can now, anywhere you have a public lighting asset that has an ANSI receptacle, that area can be used now as an opportunity to collect different types of roadway or air quality or acoustic data. Again, whether that be temporary for a short period or more permanent or persistent for a longer period. And the other important point here as well on the hardware side is with this connection to that NEMA ANSI socket on top of the light, there's no further impact on any of the assets. So you're not strapping things to poles, perhaps having to drill poles, pull fiber, anything like that. The device really is, standalone as far as that connection goes. And then on top of the hardware, to kind of talk about that scalability and modularity discussion, is the network. So all the sensors employ either the LTE-M or the LTE cellular network. So each device has a lot of the same components you would find within your cell phone. And that allows one device to go out, connect to that streetlight socket, get its power from the existing power going to the lighting, and then connect over the existing cellular network that's already there. It's a secure connection. We use private static IP address SIMs, communicating via APNs. So all of that is very secure, but it means that you can go out and take a video sensor or a speed sensor, take that one sensor, put it at one location where you're having an issue or you want to collect more data, and there's no other infrastructure needed. I mentioned fiber connection. There's no requirement for a gateway or a congregation of devices to create a mesh network. The devices really are one-to-one. So it really allows you to spread devices around your different service area where you want to collect that data. And like I said, it can be one sensor on a north side of town, one sensor on a south side of town. It's very, very flexible for those temporary and permanent installations. And then through that, once we connect to that cellular network, obviously we've got our backend software for being able to view the data, visualize the data, whether that be on a map view or a heat map. Also visualize your assets so you know where they are. All the devices report in their GPS locations. And then through that, we can do some data analyzation, and we provide you with some standard reports that summarize that data. We also very much support customers taking those reports and making customizations to them so they can really get the data that they need and provide it in an impactful way, either within their department or perhaps to other folks like counselors or cross department. So it is very flexible in that sense to get the data out of the system and be able to summarize it. There's also a very robust API for more automated connections with GIS systems to push and pull data, as well as your standard CSV export to kind of ad hoc or automated pull that data if you want to ingest that into other systems so that you can look at multiple different technology types and those data sets all on one platform like a Power BI or something like that. So I'll quickly go through the different sensor solutions and then we can get into some applications. So the first one I'll discuss is our SmartLinks radar or SLX radar. So this is really focused around mid-block speed monitoring. Typically targeted around those 2-lane, 3-lane sort of residential arterial roadways. The radar is going to monitor all the vehicles that pass through that area in both directions. It's going to give you average speed, 85th percentile speed, also look at peak speeding, and then we also have a little bit of a focus on overspeeding for some of those traffic calming areas where there are complaints or concerns about vehicle speed within those areas. The sensor looks at all the vehicles, like I said, traveling in both directions. All the metrics that I listed can be broken out by direction, either approaching or receding. But then also we want to put a focus on that overspeeding element. So within the software, you can easily go in once the sensors are deployed, set the speed limit for that specific area, and as the sensor monitors the vehicles that pass, any that exceed that speed limit will then be put into 4 different bins: 0 to 10 over, 10 to 20, 20 to 30, and 30 plus. So that also allows in the reporting that I'll talk about in a bit, how we sort of report that data and also look at different weightings on how we report the severity of the overspeeding in that area to best inform the data that's coming in and summarize that so that all the users can make the most of it. We also have a particulate matter sensor. So this single sensor here is for air quality monitoring. It looks at both PM 2.5 and PM 10, 2.5 being some of those smaller, finer particles that get deeper into the lungs from fuel combustion, fine levels of dust from construction, things like that, as well as PM 10, which would be sort of larger dust particles, brush fires, forest fires, things like that. So the particulate sensor really empowers municipalities or other organizations to manage and collect their own air quality data. So essentially, typically, there's some really amazing technology available through the federal government, through the provincial government, but usually at those lower levels of perhaps a DOT or a municipality, they can get that data very easily, but it's not, the monitoring is typically not targeted to specific areas within their community where they may be experiencing concerns. So this really supports those kind of users in a way that if they have, because of urban sprawl, now there was an industrial area that used to be 10 minutes outside of town, and now there's a residential area backing onto that. Now they can more closely monitor those areas and target the deployment of these sensors where there are perhaps perceived concerns, or also you can just put them in different areas across your municipal landscape to monitor generally your air quality, whether that's at high traffic zones, public spaces like parks, different things like that. Noise sensor is somewhat similar to the particulate matter sensor, related to that sort of environmental monitoring. Being able to have a 24/7, 365, persistent sensor out there collecting data, again, in areas of concern or possibly experiencing complaint, to monitor those noise levels. So the way that the sensor operates, it is based off of the measurement of sound pressure within the air. So it's not a microphone, it's not, sampling sounds or listening to conversations. It's really monitoring the changes in pressure and then converting that to a decibel measurement, and reporting, the impacts of that, based on an A weighting, which would be, more closely to how it impacts the, human hearing, human ear. So it reports 3 different metrics. It's going to report your lowest sound level, your highest sound level, or your peak, as well as average or periodic sound level throughout that time. It samples every few seconds, it makes a measurement, and then it reports that data in at a scheduled interval, typically 15 minutes, but we can get that down to a more granular, 5-minute reporting interval, depending on specific applications. So where do we see the applications? It's, in my area, it's ports. How does noise from the port impact nearby residential areas? Construction site monitoring, especially for long-term construction, in, urban areas or residential areas where residents could be impacted on a daily basis, and also could, look at, maybe construction starting too early or going too late into the evening, as well as, different rail applications where we have those rail yards that can cause some external noise, as well as just, roadway applications, looking at sound barriers, different things like that. Also, again, just monitoring throughout the community at specific targeted areas, high traffic areas, truck routes, different things like that, to really understand what the baseline of the noise is in the community, but also understand, is it at, an acceptable level, or is it something that needs to be monitored more closely, and perhaps look at, future mitigation. And then the last one of the sensors that I'll go through is our video sensor. So the video sensor, it's really multi-application, traffic counting, asset monitoring, and community safety being some of the larger ones. One that I don't have here that's actually come to the forefront within the last year or so, as well as cost-effective road condition monitoring, supporting, a DOT or a municipality to have their operations staff be able to very quickly dial in and check on specific roadway locations, from their home or from their office, to determine if there's any salting or plowing needed and what areas need to be focused on, or prioritized. The standard camera is a 1080p dual lens camera. So as you can see here, one device is going to give you 2 fields of view. This is a great example of sort of that roadway application. So basically it sits on that street light. You have a view to the left and then also a view to the right. So for every one device that goes out there for our 1080p camera, you actually have 2 distinct fields of view that you get with that single device. And the way that cameras operate, they are a little bit different, where they are cellular devices. So basically the way that the cameras operate is that they have an onboard SD card for continuous storage at the edge. So that camera is constantly recording at the edge onto the device. We've got multiple options for storage depending on what your requirements are. I'll talk about sort of the standard model, which is a 512 gig SD card in that 1080p device. That's going to give you about 22 days of storage on the device. So within that 22 days, if you have an incident, if you want to pull video to check on traffic conditions at a certain time, you can go in and you can retrieve that video through the Milestone VMS software. You plug in the time periods that you want to retrieve, and then you execute the retrieval, and then it's going to pull that video over the cellular network, and you can easily access that video, right from your laptop in your office. As well with these devices, they are cameras. So obviously they do need to support some level of streaming. So our devices can certainly stream on demand, again, through Milestone. You just click into the Milestone software, very easily click a button on that camera and start streaming. We set the default to the stream at about 1 minute, just so, somebody doesn't click the button and then sort of walk away for the weekend. But all of this is customizable. So we have some customers that have applications where they need 2 minutes or 5 minutes of streaming. Some customers don't want any streaming. They just want the video retrieval. So I'm kind of speaking standard offering, but just to add that in, there is a lot of flexibility and customization available here. So I'll show a couple of samples quickly here. So this gives you an idea. So this is one lens from the 1080p camera. This is mounted, I believe, about 7-8 meters high. So to give you an idea of the field of view, the width here is about 30 meters close to the camera, and then back at the intersection or the crosswalk is about 70 meters. So you get quite a wide field of view. Get descriptions on different vehicles, people. So it is helpful in that sense too when we're talking about community safety. Important to mention as well, though, for the 1080p version of the camera, and this was very purposeful, there's no ability with the 1080p to read a license plate or facial recognition or anything like that. That's to sort of fit in well along with the passive monitoring with most privacy policies that municipalities have. We've been through multiple PIAs with no issue. So being able to provide a level of video that is helpful and also a deterrent, can also run different analytics, which I'll get into in a minute, but do that in the least intrusive way possible. And we also have a video here from nighttime. So this would be sort of that other side of the camera. And you can see here how it operates at night. Obviously, it is meant to be installed on a street light. So there is some reliance there on public light source. And that's something that, myself and Steve and my team and the folks at ATS can certainly support on as far as site selection and location selection when folks are looking at deploying. That's a big part of what we do. And then for some of those more, security focused applications or unlocking different types of analytics, we do now have a 4K video sensor that we've brought to market as a next generation. In addition to the 1080p, which is still our standard offering. The 4K is a single lens, operates the same with the passive monitoring and the onboard storage. But also what's nice about the 4K is there's 3 different field of view options that customers now can choose from to better support sort of their applications at that higher resolution. This is just a quick example to kind of show you the different options. So this is your standard 120 field of view. This is a pretty high pole. This is probably, we're looking at about a 9-meter pole here. So this would be your 120 like you get with the 1080p that I showed. And then, but you have other options for an 80-degree FOV for slightly more zoomed in. So you don't quite get that same wide view you get with the 120, but you do get a more focused view. And then even more so with that 40-degree FOV You can really hone in on a specific area. So again, a lot of security applications. It's not guaranteed, but we've seen through our testing, it can capture all or part of a license plate manually if you are having issues with, say, illegal dumping or vandalism or things like that. So I'll say the 40-degree FOV is a little bit more security focused than the other applications and community safety focused, but it also does unlock some new analytics, primarily the ability to provide pedestrian counting, which is something that at the 120-degree FOV is just not possible based on the wide field of view and the resolution. So I'll go through a few applications of the different sensors. Hopefully that'll be a little bit helpful. Yeah, Steve as well. I know you know these quite well, so at any point, please feel free to jump in and add your expertise as well.
So on the radar, Mike,
yeah.
Someone did have a question in the chat since we're on the radar. What's the maximum number of lanes that the radar would be able to track and report?
Typically, it's in that sort of 2 to 3 lane. It's kind of focused on, mid-block, like I said, residential, arterial. For the higher lane, you probably want to go to a different technology. It can work on 4 lanes. We just see a bit of a degraded accuracy when it comes to the traffic counting portion, because as it detects that vehicle and detects that speed, it's also providing account of that. But yeah, typically we want to target these 2-lane, 3-lane roads, kind of your low cost, focused on, speed validation and areas where you're looking at traffic calming measures.
Yeah, I'd say on a multi-lane arterial, best practice would be to have a sensor on each side of the road. So you're just focused on sort of the inbound or the outbound, depending on where you've installed it. That would be the best option.
Yeah, totally. And that's actually a great point, Steve, because we do have some applications where we will put one on each side of the road. And within the software where it reports both directions, we can just have it focused on one direction of travel on the nearest lanes. And then you basically just utilize 2 sensors to fill out the roadway. And similar with sometimes you have those median mounted double davit poles. That would be another application. Where really to get the proper coverage, you do it exactly what Steve said and have sort of a radar on each luminaire on the double davit pole, and that way you can service both sides and still maintain that accuracy. So yeah, that feeds nicely into what's the primary use case for the radar sensors. It's really looking at sort of speed validation and traffic calming. So obviously, we're going to put the speed sensors in areas where there's public complaints about speeding, there's concerns about speeding, school zones, public parks, different things like that, as well as obviously, citizens calling to cities and councilors with their complaints. So the radar sensor is a really low cost way to detect the data on the roadway, but also do it in a totally discrete way. Most of us are not looking up at the streetlights, especially when we're driving, or even noticing that there'd be a device on top of that light. So it really provides a true set of data without, impacting the way that the drivers are behaving on the roadway. And again, it's very modular. So we have some customers that use these more persistently and have them there for longer periods, not just to look at the traffic calming, but also to have a more long-term traffic count within those areas, especially if things are changing in the areas. But it also really does support the ability to confirm that the problem is there, implement some sort of mitigation, whether that's, driver feedback sign, targeted enforcement, something more permanent, like adding like speed humps to the roadway, but have that sensor there collecting data for the entire period. So you can really make a decision, a database decision on, did the mitigation, did what we put in place actually work? For a driver feedback sign, maybe it only worked for a month or 2 and now the problem's back. So it really does allow for, evidence-based, database decision making.
So Mike, there's another question there just on the radar.
Yep.
Accuracy during different weather conditions. My assumption would be because it's radar, we're not worried about occlusion from rain or snow, but what would be the accuracy under snow and ice and rain?
Yeah, great point. So it can be impacted by precipitation, particularly like at the beginning, like when that rainstorm first starts and things like that. But the way that we handle that is within the software, the radar reports what we call a weather confidence. So we set a threshold for that weather confidence. If the radar starts reporting in erroneous detections, they get captured, that confidence level drops below the threshold, which is like 90% or something like that. That radar stops reporting. So yes, you do miss some of that data, but it stops any erroneous detections from, torpedoing your entire data set. And with the reports that I have up here, I don't actually think that I have it, but one of the reports, one of the numbers that's provided is actually the weather confidence interval for that period of time. So if you get a report and it says, 90, that means that the sensor essentially probably was active for 90% of the total time of the report. So if it's a weekly report, you had a snowstorm. So you can really appropriately put the lens on that data as compared to other weeks. If you're comparing week over week or month over month, say, hey, that count seems very low or the speeds seem low. Well, you've got that weather confidence there to kind of inform you how what the uptime of the sensor was, I guess is the best way to put it. So with the reports that we have here, this is just a sample. So really the focus here is that we've got two different types of reports. We've got multi-device reports and we've got single device reports. So on a multi-device report, you can have your entire inventory laid out. You can get all the metrics, you can get them by lane. This one specifically here, I know it's a little hard to see, I apologize, but this is breaking out over speeding and it's breaking it out by bin. So this would be sort of your target enforcement, your highest speeding report. It's going to tell you what your vehicle counts are in each of those over speeding bins. And it's also going to give you the top 3 times for the previous reporting period, which is typically a week or a month. It's going to give you the top 3 times of day when the top 3 hours where your speeding is the worst. So really providing some actionable data to say, look, not only is there speeding here, but here are the times when it's really occurring, not just at a high level, but also the bins are all ranked by severity. So a car traveling 30 plus over the speed limit is going to have a higher ranking than a car traveling 5 kilometers over the speed limit. So that's really how we design those bins to provide those sort of enforcement and speeding reports. You can also get reports focused around a single device where you get a little bit more granular data. It's going to remind you of the location of that device. It's also going to give you the total count of the vehicles, and it's going to give you, how many vehicles are in each of those speeding bins at that location. And it's going to compare that to the previous week or the previous month. So you can really use that as a tool if you're implementing traffic calming measures to have a comparison of how impactful those measures are and if they're improving the situation.
I'll just expand on the reporting just quickly, Mike, for those that are listening. So we do have a customer in Alberta where the enforcement by location report is sent automatically to their police department weekly, and then they're deploying officers in those high risk areas based on the report to conduct speed enforcement. So it's real world actionable like very, very quickly.
Yeah, absolutely. And that is another good point. So the nice thing about these reports is they're available within the software platform as well as data history to dive deeper. But like Steve said, you can have these reports set up to email to multiple people that may not even want or need access to the software, your local police department, different counselors. So that automated reporting feature is certainly flexible to be able to share that data with more people than just sort of the primary users of the SmartLink software. So another application, this is for the video sensor, would be mid-block traffic counting. So with that, the 1080p or the 4K video sensor, we have the ability to, once that camera is in the field, deploy edge analytics on the device that perform traffic counting at the edge and then report traffic counts and classifications back into the SmartLink software. As you can see here, very similar reporting format to the speed sensor. However, we do have a couple extra functions here. It's all by direction as well, just like with the speed sensor. But it's going to give you 3 different classes of those vehicles that it's counting at the mid block. So we've got motorcycles, small vehicles, and large vehicles. So in addition to that sort of total count, you can also break that out by direction, but you can break out the different classifications as well of which types of vehicles are traveling on that roadway, and those even more granular can be broken out by direction as well. So the data reported, kind of Steve touched on this, but it's weekly, it's monthly, but the biggest thing here is you can get that 24/7 count data. So now you're filling in the gaps of what you're already collecting at your intersections to say, okay, well, what are the counts upstream and downstream? And again, it's temporary or permanent. Some folks use these as sort of a permanent count station. Some people, they're temporary, but maybe it's longer term. So you want to have like a 6-month count, maybe a year to go through all the seasons and then move the device. And then there's another opportunity to do more of those like short-term counts, move the devices around at a higher frequency.
So I'll add to Mike, just when you do sort of a cost benefit and the long-term cost of ownership, with this solution for mid-block counting versus, sort of traditional loop-based permanent count station, when you consider the cost of the loops, the installation, you're cutting up your roadway, you have to install a cabinet, you have to power the cabinet, and then the maintenance long-term on those sort of things, versus putting the camera on your existing street light. I mean, the cost is significantly less than what it would cost to install one permanent count station. So pays for itself, really.
Yeah, absolutely. Another application for the video sensors, kind of getting out of the traffic space a little bit, is really around that sort of community safety and asset monitoring. Being able to rapidly deploy cameras in public spaces like parks, downtown areas, sports fields, as well as storage facilities, works yards, different asset monitoring, but really be able to quickly deploy video devices for areas that are experiencing different types of issues, both as a deterrent, but also to be able to actually collect and action video if there is an incident. And again, like I mentioned, the video is all passive monitoring, so typically that fits in well with different privacy requirements or PIAs for specific areas where they don't want to be constantly streaming data. It's kind of, we just want to look at the data when we know, or the video when we know there's been an incident, so that we can appropriately action that, whether it's sending it to the police. There are a couple customers as well that we have where the community has deployed the cameras specifically to be able to just get the video to the local police service, because that is the most seamless way to do that, depending on the ownership of the lighting asset. For this specific park, I will mention as well, it had multiple vandalism issues, but also to install another type of camera technology, with the trenching that would be required to access the existing poles and things like that. The cost was in, the $10,000 to $15,000 range to do that. So for this specific customer, the rapid deployability where they already had lighting in that area, made, our solution a little bit more cost effective compared to some others, and they were able to deploy it, very quickly. As well, going back to the analytics, so to piggyback off of that, the other option we have for those edge analytics is you can do intrusion detection or loitering monitoring. So essentially, you can set up a boundary. We would set up the analytics, and then you can have a notification sent to a user or a group of users if there is someone in a specific area at a specific time that they shouldn't be there. More focused around that sort of real time, being able to action an incident, recognize an incident while it's happening, and then determine how to proceed with that. This is obviously testing we've done at that park location I mentioned, but a lot of the applications we'd see for this would be no-go areas or no-go areas at specific times, like works yards, stormwater facilities, like different things like that, where you have more of a fenced-in area. And maybe during the nights and on the weekends, nobody should be there. So you really need to know if somebody is in that area when they shouldn't be, and be able to call local law enforcement, on-site security, different things like that. A newer application that we've looked at as well with the video sensors and kind of using that counting analytic in a different way is stop sign compliance. So being able to look at non-signalized intersections or small signalized intersections. Are people really stopping when they should be, and how often is that occurring? We did run a small test. During the test of the application, it was very successful. We had 94% accuracy of those nonstop detections. Where we implemented this test was an area of concern. And within the 7-day period, as you can see here, the analytics actually identified that over half of the vehicles at this specific stop sign were failing to stop or failing to come to a complete stop and rolling through that stop sign and that intersection. So certainly, when we talk about safety and Vision Zero, obviously nonstop compliance is a big part of that, and being able to recognize that and implement different solutions is going to be critical to highest level of roadway safety. The last couple applications here I'll touch on, and I'm going to go pretty quick because I know Steve has a couple additional things to touch on and want to leave some time for questions. We talk about localized air quality monitoring. This is really what that looks like. This is more of targeted local monitoring, but over a complete service area. So deploying these particulate sensors in a way or in specific areas, but really being able to touch more areas and get more data points to really understand what that local air quality really is, rather than just relying on the one or two stations that may be in the community, or perhaps they're not in the community, they're close by, they're at an airport, different things like that. And then just on the visualization piece, a really important one, especially I find for the air quality that's really impactful, is having the heat map in SmartLinks, and not just to show you real-time data, but it's all customizable by dates. So if you want to compare year over year, you can go back in time and you can do that and make a comparison of the air quality, during specific events like a forest fire or something like that. And then the final one that I'll talk about is the noise sensors. Again, looking at, targeted deployments of noise, specifically in areas of concern or looking at areas of public complaint. The graph here, this is showing you your three metrics reported: your peak, your periodic, and your lowest. But one of the important points here is, I mentioned the reporting interval of 15 minutes. The sensor still, when it sees that peak noise for that period, when it's reported into the software, the peak noise is reported in with a timestamp. So it doesn't matter what your reporting interval is. Once that peak noise is measured, or when noise exceeds the threshold, you will get a specific timestamp to that event to be able to trace it back more efficiently. And that kind of goes into the next topic here of co-location of sensors, which a couple of our customers are doing now, kind of looking at dual deployments using this power tap accessory. And one of the drivers of that is pairing cameras with noise. So when you go back and look at those timestamp peaks, you can then easily go back with that retrieval function in the software, the camera software, and pull small snippets of video from the periods where those peaks are seen, and ideally be able to provide some correlations with what the cause of those excessive noises are. And yeah, I think I've hit on all of these topics, but I think, you know, the sensors really are modular. They're low cost and they're low risk. There's no MOQ or anything like that. You can test one sensor, one type, you get the types you need, you locate them where they are. Sensors install in minutes. They support both your temporary and your permanent deployments. The software that I've discussed is all cloud hosted. It has, you know, we have a set of standard reports, but it's a very open platform with a lot of customization options. All the sales support, the training, and the technical support to deploy this stuff, and ongoing support for the customers, it's all provided by Liveable Cities as well as our partners at ATS. And really all the multiple application offerings, that's cross-departmental. So there's benefits to this data across multiple departments, which provides, you know, typically a larger applicability, and multi-benefit. And then the final one I'll touch on is, you know, everything's designed and engineered and manufactured in Canada. We're a Canadian company for all our Canadian customers. The data is all hosted in Canada. But I also wanted to touch on, I know we have some US folks on the call as well. So we do have US-based hosting options for folks that do require that in the United States. And with that, I'll give you guys a little break for my voice and pass it back to Steve.
Thanks, Mike. That was great and super informative. So I just wanted to, before we run out of time, touch on, I had mentioned it earlier, GPOs. So for those that don't know, GPOs like Sourcewell, Kinetic, Canoe are cooperative purchasing programs that help public sector organizations buy goods and services more efficiently by leveraging the combined purchasing power of many members. In practical terms, they establish competitively solicited pre-awarded contracts with vetted suppliers, much like us at ATS. So municipalities, school districts, other agencies can purchase faster with less administrative, with less burden, while still maintaining procurement compliance. The value proposition is pretty straightforward, really. You reduce the tendering effort, shorter purchasing timelines, and access to preferred pricing and standardized terms. And then lower overall procurement risk. That frees up staff time and budgets to focus on service delivery rather than running repetitive RFPs for common needs. So we are pretty proud and excited we awarded a Sourcewell contract for the SmartLink sensors. So that Sourcewell contract is, if I'm not mistaken, it's across Canada and the United States. And then also ATS is a member of Canoe and Kinetic GPOs. So if your organization is not a part of a GPO, I would encourage you to go to your purchasing department and ask them why not, because it's certainly a huge benefit. So when you look at sort of how these things work, ATS being pre-approved through a Sourcewell contract basically means you don't have to jump through all those extra hoops that you would if you wanted to go out and source a new technology, going through speccing out equipment, advertising the bid, and jumping through all those hoops that you would have to. The Sourcewell and GPO contracts do that for you. All right. Then next steps. I hope everybody found this interesting and educational. So ATS, AGS, and the team at Liveable Cities is here to help and answer questions. So if anybody wants to talk about specific use cases or have sort of more deeper questions, you can reach out to either your ATS rep or info@atstraffic.ca, and someone will get back to you right away. I think there was one question in the chat, Mike, about mid-block counting, if a car parked, would it count at the time of parking or when it moved again? My assumption would be it has to go through that detection zone in order to be counted.
Exactly, yeah. It depends on the detection zone and how it's configured. When the vehicle passes through the detection zone, just like you said, it's recognized as a unique vehicle, and we have a setup and optimization process that we go through when we roll these out. And that's to not just set up the analytic, but to look at different periods, typically peak periods, to monitor for accuracy and make any changes that need to be made through that optimization period in the first few weeks that the devices are deployed, so that we're, maximizing accuracy and minimizing, specific detection. So if we saw an impact from a specific parking area, we would adjust accordingly so that it's not skewing the mid-block count on the roadway that we're focused on, that the customer's focused on.
Exactly. So then there's a question there, and I was anticipating this one. How much does each device cost? So short answer is it's going to depend on the application, whether you're doing the speed, the particulate, noise, or video, and then your deployment. If you're buying multiple units, obviously we can reduce costs based on volume. But just to give you a ballpark, the speed radar units are in the 550 per unit range. So when you compare that to, say, some of the more traditional data collection devices, whether they're radar based or tube counters, I mean, those will run into the thousands of dollars, if not, $5,000+ per unit. So these units, budget wise, significantly reduced. The noise sensors in that same range, and then the video, they're about 2,000 per unit, and then there's obviously the service maintenance annual fees with that, but that can be scaled based on how many units you have as well. So we're happy to, if someone's got a specific use case, we're happy to do sort of a site assessment and then put together kind of a custom quote for everybody. I don't know if there's any other questions. Keaton, I think everyone's using the chat, but not the Q&A. That's fine. Okay, well, I think Keaton, if there's no questions, I think we can look at that. We're with like 2.5 minutes to spare. So
right on the line. Just want to remind everybody, the recording of this webinar will be put up on our social media pages, our YouTube, and everybody who attended today will be receiving a follow-up with the recording link and some additional information and contact info. We want to thank you all for attending on behalf of ATS Traffic, AGS, and Liveable Cities, and we'll let you get back to your day.
Thanks, everybody.
Excellent. Thanks so much, everyone. Thanks, Steve.